Hello friends, today this is the first video of this series, and in this series we will discuss about why Gearbox exists. So in this topic, before starting this, first we will understand that what is the system. So in the cars or any vehicle, so first of all there is a engine, then there is a transmission. For coupling these two things, there will be a clutch. However, a flywheel is connected with the engine, you can consider. And after the transmission, it powers the wheel. So, this is a general system of the ICE vehicles. Here, ICE stand for the internal combustion engine vehicles. So, this is generally we can say petrol, diesel, or CNG vehicles. So, my first question is why we need a transmission here? And there is also another question why electric vehicle doesn't need a transmission? If we talk about electric vehicle, EVs, so it has basically a motor and then it powers the directly the wheel. And this motor is controlled by the MCU, which is motor control unit. Okay, so if we compare both things, there is a difference majorly on the transmission. Here, engine is the power generator, it creates the power. Here, motor is the power generator. Here, motor creates the power. But the question is the same. Why we need a transmission? So we will discuss about more in this thing. So before moving to the next segment, first we will understand what is the basics of the power. So as we have studied in the academics that power is equal to 2 pi and T divided by 60,000. It is in kilowatt. So here we can say P is directly proportional to N and T. Here N is the RPM and T is the torque. These RPM and torque can be at any location, like at input, input power, or maybe at output power. So input power is at the engine and output power is at the wheel. Okay, so theoretically input power will be equal to output power. If we consider that a complete transmission is 100% efficient, but mostly it is not. For theoretically, we are considering this. Okay, now again focus on the this formula. Power is directly proportional to N and T. So if we consider a engine which is around, we can say, 50 HP. So its power is constant. P is proportional to N and T, and this is constant. We cannot change the power of the designed engine. This is the designed engine which was designed for X vehicle. So if we design any engine, we cannot change its power. So in that condition, power is constant. But when we are going straight, then we need more RPMs. And when we are going to the hill, then we need more torque. So if the power is constant, if we increase n, then torque will reduce, because we have to maintain this relation of constant power. If RPM will increase, then torque will reduce. Or if we need a high torque, then RPM will reduce. So it justifies the this relation. When the power is constant, these are when the power is constant, then these are inversely related. Okay, we understood up to this level. So let's now come back to the our topic, that is gearbox. Now we will understand. Let me draw one gearbox. Suppose this is a input shaft. This is driven gear which is mounted on the lay shaft. Here these are the bearing, another bearing. This is constant mesh here. Don't worry if you don't understand the any term. We will discuss later, sure. And this is the main shaft. These two gears are in the mashing. You can consider one another bearing here also. One bearing here. Okay. So this is the input shaft. This is the lay shaft. And this is the output shaft. So this is the very basic two-stage gearbox, the simplest form of the gearbox. Suppose this is the number of teeth, 10. This is 20. So here we can see it is the ratio of 20 by 10. R1 is the 2. And again, if we consider this is 25 and 10, driven by driver R2. So this will come 0.4. Okay. So here total ratio is, here total ratio will be R1 multiplied with R2, 2 into zero point 0.4. So this will be zero point 0.8 gear ratio. So why I calculated the total ratio and why it is important in the gearbox? So if you see, we have achieved gear ratio of total 0.8. Okay. So what it will do? Suppose if input torque is 100 Newton meter. So what will be the output torque? We have to simply multiply it with the total ratio. So output torque will be 80 Newton meter. And in the same way, what will be the output RPM? Consider input RPM is the 1000 and our overall gear ratio is 0.8. So it will come 1250. So what we understood here, that this is, sorry, this is output RPM and this is output torque. When we considered constant power, the input torque was 100. It reduced to 80 and RPM was 1000 and it increased to 1250. So it justifies the relation of constant power. So this is the main thing that gearbox do. It changes the torque, it changes the RPM as per our requirement. And this requirement can be set by changing the gear ratio and we can get desired output of torque and RPM. Okay, up to this we understood the relation of the torque and RPM. Now we will proceed for the very important topic, engine characteristic curve. This concept will explain why we will need transmission gearbox. Consider a graph. This is vertical line, this is horizontal line. And consider horizontal as RPM and this is torque. So what is relation between these? As per practical engine characteristic. So suppose this is 100, 200, 300, 400, and more like then something 1000 RPM. So what will happen initially when the engine starts? The torque will start to increase. Then what happens after the some torque for what the engine is designed? After that, it will lose torque suddenly at some RPM. Okay, and in the same way, we will understand the one more curve of engine characteristic. So this will be power, and this will be again RPM. 100, 400, 800, something 1000, and it also follows like same. Initially it is same, then power is constant up to some RPM, and then it reduces slightly. So here what we can see that there are limitation of the band of the RPM. For if we suppose if we want to use a torque of something here and here, there is no use of being in the this range, because this is giving very less torque, and there is also sudden less torque. So in most cases this will be our usable range. So just for example, it will be between something 300 to somewhere 800 RPM. And now if we look at the power RPM curve, here also we cannot work in this zone because it has very less power, and it also has very less power. So these are not efficient zones. Again, we have to stick to the this range. So this may be again like same around 300 to 900. This is just for example. But here what I can teach you that there is a very narrow range of the RPM in which we can work, and here the limitations come, and the limitation is when efficiency, sorry, when efficiency is required, we have to move in narrow range of RPM. So this is the limitation of the engine. To cover this limitation, there is a thing used that is called gear box. Here this thing comes into the picture. Okay, so I will now explain what the gearbox will do here. Just take an example that engine RPM range is 1000 to 2500 RPM. Every engine has some RPM range, so this we are considering here. But what if we need RPM at wheel 5000? How we will achieve this? Then this will be a major problem without the gearbox. So using the gearbox, we can simply suppose input RPM is 1000. If we use gear ratio of suppose 0.2, then it will increase to RPM 5000. And why we need higher RPM of the wheel? Just simply to get high vehicle speed. So this is the main concept why we need a gearbox transmission when we are using ICE engine. So I think gearbox concept is clear. Now I will move to the electric vehicle. Why we don't need a transmission there? What actually happens there? So I will draw a characteristic curve of the motor here. For example, here is again torque, here is RPM. It will start from 0 RPM to 20,000 RPM. So here, suppose this is 10, 20, 50, 80, 120 Newton meter. So actually what happens? Electric motor can provide peak torque even at the 0 RPM. So how this graph will look like that? So here in the wide range of RPM, the torque may remain constant and then it may drop slightly. So here motor usable range is very wide usable range. So motor can easily provide 20,000 RPM at even very high torque and even very high RPM. So this is the advantage of the motor. So this is the reason why we don't need a gearbox here. No need. I hope this is clear. If you need to understand any more topic related to this, please comment and I will get back to you. And thank you for watching this video. We will meet in next video. Thank you.